Hey, my name is Ernesto Tagwerker, and I'm here to talk about RubyMem, the Leaky Gems database for Bundler. Now, this is a relatively new project that helps us find dependencies in our application that are known to have problems with memory usage. If you have any questions or comments, feel free to shoot me a message on Twitter. My handle is etagwerker. Now, I'm originally from Argentina, so if you hear any words that sound funny, it's because English is not my native language. If you have any questions in Spanish, the good news there is that I can help. I have been living in Philadelphia for the past 4 years with my wife, daughter, and son. I really like it here. There is a small Ruby community that I help organize. Now, due to COVID, I've been spending a lot of time at home working and taking care of my kids. Now, my daughter loves to draw, so I love drawing with her, and she really wanted me to share this drawing with you. This will explain why you'll see some drawings of my own in this presentation. Now, they're not as good as hers, but I tried my best. And one last thing about me is that I love open source. I wouldn't be here speaking if it wasn't thanks to open source projects like Ruby, Rails, and many, many more. So I try to get back to the community as much as possible. I'm one of the maintainers of Database Cleaner. You might have used that gem in the past. It helps you keep a clean state of your database between test runs. I also maintain Next-Rails, which is a toolkit for your next Rails upgrade project. It helps you with things like dual booting your Rails application and finding incompatibilities with the next version of Rails. And Skunk is a project that helps you assess technical debt in your Ruby applications. It looks at all the files in the application and it tells you these are the most complex files which lack test coverage. It uses tools like RubyCritic and SimpleCov to do this. If you're interested in any of these projects, please feel free to check them out on GitHub. I'm also the founder of Ombu Labs, which is a small software development shop based in Philadelphia. We love Rails, we love Ruby, and we love working remotely, among other things. Now, if you're interested in working in challenging projects and working remotely from anywhere, feel free to check out this page. We are currently hiring, and we would love to hear from you. A couple years ago, we found ourselves working a lot on Rails upgrade projects and Ruby rescue projects. So we decided to launch a service called fastruby.io. In the work that we do with Ruby rescue projects, we end up working a lot on performance optimization, which requires us to look into the memory usage of not just our clients' code bases, but also their dependencies. A lot of the tools I'm going to talk about today, we use on our client projects on a weekly basis. And when I talk about memory issues, I'm not talking about you forgetting something and then realizing about it. I'm talking more about applications using way too much memory, so much memory that it becomes a problem. And that happens with Chrome sometimes on your Mac computers. So I'm talking about memory issues as in RAM issues. Sometimes I'll be talking about memory leaks or memory bloats. Sometimes the root cause will be in your Ruby gems. Sometimes they'll be in your application code, and sometimes they'll be in C extensions within your Ruby gems. So this can be a very tricky issue. I think it's easiest when we look at it with a story. So it is story time. A few years ago, my boss comes up to me and he's like, "Hey, can you help me with my project?" I'm like, "Sure." How can I help? Well, can you make my GIF search engine faster? And I had never heard of this project before. So I asked him, yeah, I mean, maybe you can show me what it looks like before I start working on it. And he's like, yeah, sure. Basically, you have a search box, you plug in a keyword, and you get 5 GIFs. Very simple. And I'm like, yeah, that is super simple. I wonder how I can make it better. And I say, okay, maybe I can add a simple cache to it. Behind the scenes, I see that it's a Rhoda application. It is not a Ruby on Rails application. I work a lot with Ruby on Rails, but this one in particular is a Rhoda application, which is another popular framework in Ruby. It's also a rack-based application framework, just like Rails. When I look at the search action, I see that it's using a query object. So I dig deeper. And I see that the query object has a search method which makes third-party requests to the Giphy API. And Giphy is a GIF directory. There are a lot of GIFs in Giphy. So if you think about it, this is basically a wrapper for the Giphy API. And I think, okay, I'm going to write my cache in Ruby with a hash. Simple. I work for a couple of hours and I come up with the next solution. It's a query cache constant that is a hash object. I save the values that I get from the Giphy API in this cache, and I use the keywords as values. So this guarantees that I won't contact the Giphy API more than once per keyword. So I get it code reviewed, tested, everything looks fine, and I ship it. I reach out to my boss and I say, hey, I just shipped a bunch of changes, which included my caching solution. I also bumped the version of Rhoda, REST client, and Puma, and I upgraded the Heroku stack as well. My boss is happy, the users are happy, and my boss is like, good job, Ernesto, everybody's happy. Great, I take off for the day, go home, and don't think about it anymore. The next day, I hear that users are seeing errors in production. They can't find the laser cat GIFs that they want, which is terrible. I know. And I feel awful because I'm the last one to deploy things to production. So I say, weird, I'm going to check the logs. And sure enough, when I look at the logs, I see that there are a bunch of memory usage error messages. I'm like, error R14, memory quota exceeded. What is that about? Before I can take a look, my boss pings me on Slack. Hey, I noticed this weird behavior in our production's memory graph. I check out the Heroku dashboard and I see that memory usage has increased constantly since I deployed the application. I see that 12 hours into this new deployment, we run out of memory. And yes, I confirm that looks bad. We run out of memory overnight. But I'm hesitant. I say, my code was so small, there's no way it's my code's fault. It's probably Rails' fault. But then I remember, hey, I'm not even using Rails, so maybe it's Rhoda's fault? After all, I did deploy a version bump for Rhoda. So maybe that's it. My boss, who has a few more years of experience, is like, what's more likely, that Rhoda has a memory bug or that your code has a memory bug? Well, maybe you should check the changelog for your latest deployment. And I say, Sure, good idea. I'm just going to start debugging this. And I ask myself, what tools can I use? I know that Ruby has some tools in the standard library. So I say, okay, I'm going to use object space to find out how many objects are getting instanced and kept in memory between the requests that I'm making to the application. So I add this snippet that will count all the object instances in the Ruby memory, and it will tell me which types are the most popular right now. And I start using the application with this new method, and I see that hashes and strings are growing. But I'm still not convinced about this behavior. I'm not convinced that my application code is the problem. So I'm not sure. I'm going to use RackMiniProfiler and Memory Profiler to look into it a little bit deeper. So I add these gems to my application, and I require the libraries right before I start my application. The good news is that RackMiniProfiler gets loaded as a Rack middleware, and Rhoda is a Rack-based framework. So with a one-liner, I can add RackMiniProfiler to my Rhoda application. And this allows me to add parameters to the requests that I make. Like this one, if I add pp equals profile memory, I can start seeing information about the memory usage of my application. I can see the allocated memory by gem and by file, among other things. I can even see allocated objects by class. Now, I need to see the behavior of the memory across different requests and see if all the objects that I'm adding to the application are getting garbage collected or not. After a few hours of debugging this problem, I realize that my code is the root cause of the problem. And I go back to the changes that I shipped to make sure that that is where the problem is. Now it becomes obvious that the cache has limited memory space, but the queries that I receive could be infinite. People could search random keywords and my application's memory would just fill and fill and fill to eventually run out of space. So my solution, it seems that it's causing a memory bloat. In order to fix it and to find a better solution, I'm going to revert my change and deploy. And when I do that, I notice that the memory usage in the Heroku dashboard drops dramatically. Okay, I fixed that problem. My boss is like, great, what was the root cause of the memory leak? And I explain, well, my cache could end up using infinite memory, but we only have 500 megabytes available in our Heroku dynos. And then the next question, of course, is why did you take so long to fix it? And I try to explain, I shipped so many changes that I didn't know which one caused the problem. I didn't know whether the leak was in my application code or in my dependencies. All right, so story time is over. Let's see what lessons we learned with this. First one is anyone can introduce a memory bloat or a memory leak. It can be you, it can be one of your teammates, or it can be a well-intentioned open source developer who is just trying to make their library better. It is so easy to introduce these problems to your application, but it is not as easy to find the root cause of the problems. It gets even harder if you're constantly deploying changes to your application and you can't let your application instances run over time to see how they behave with memory usage. The good news is that there are great profiling tools in Ruby. I mentioned just two, but I know that there are many more, like Flame Graph, derailed benchmarks, and many, many more. So after this particular experience, we asked ourselves this question. If only there was a way to quickly answer this question. Is it my code or is it one of my dependencies that is leaking memory? And that's what Bundler Leak set out to fix. To answer that question, are we using any dependencies, any Ruby gems that are known to have leaked memory in the past? And in order to answer that question, you can quickly install the library in your gem file. After you do that, you can run bundle leak, and it will tell you whether there are dependencies that are known to be leaking memory or not. So if it doesn't find anything, you can say, neat, none of my dependencies are known to be leaking memory. So I feel confident that the root cause is within my application code. I'm going to debug my application code. On the other hand, if you run bundle leak and there is an issue, it will report it like this. It will tell you net HTTP persistent 300 has a problem. And it will link you to the source of the report of the memory leak. Then you can take a look in your gem file and see that, yes, you are explicitly trying to use that version in your application. And you might ask yourself, do we need to use that particular version, or can we upgrade to version 301? Maybe you can just bump that dependency. So you do just that. You change the dependency declaration to use 301 and you bundle update. After you do that, you run bundle leak again, and great. Now you see that there are no dependencies that will cause any problems. The awesome thing about this is that in a few minutes, you fixed a problem with memory leaks in your application. There was someone who reported that leak to net HTTP persistent. There's someone who took the time, probably hours of their time, to patch that problem. So with bundle leak, what you can do is quickly use that information to save time in your day-to-day. And you can say, okay, no more leaky dependencies. Now let's check again. Are we still leaking memory? If so, then you probably want to look at your application code and see what you're doing to cause problems with your memory. Here are a few details about the implementation we did with this project. First of all, this project was inspired by Sergey Alexeyev's project called Leaky Gems. He started a project that would track all those reports of all the gems that had problems with memory usage. It was basically a README that people could submit pull requests to. What we did is we turned this easy format into a machine readable format in order to build a command around it. So we turned that particular project into the RubyMem advisory DB. And you can check it out on GitHub. There is a directory that has every single gem that is known to have had an issue with memory leaks. And you'll see that our report looks like this. It has the gem name, the date it was reported, it has the versions that are affected, and it has the versions that have been patched. So it provides a clear path for you to fix this problem. Another thing is that Bundler Leak is a fork of Bundler Audit. If you're not familiar with Bundler Audit, well, It is a really cool tool that you can use to find problems related to security vulnerabilities. Bundle Audit will tell you whether you're using a vulnerable version of a Ruby gem or not. And it will tell you where you can find more information about it. If we look at them side by side, we can see that Bundler Audit and Bundler Leak are very, very similar. In order to run Bundle Audit, you just run bundle-audit. To run Bundler Leak, you just run Bundle Leak. So just like Bundler Audit has the RubySec Advisory DB, we have the RubyMem Advisory DB. So they're very, very similar. And one note about this is that RubySec and RubyMem are not connected at all. RubyMem just forked RubySec and used the same idea, but as a source of data, it used known leaky gems as a source of data. So why isn't RubyMem part of RubySec? Well, the truth is that not all memory leaks are security vulnerabilities. Some might be, and maybe it's a good idea to integrate both projects around them, but many of them are not actually a security issue. Now, there are a couple things that we want to do with RubyMem and Bundler Leak. We've noticed that the more reports we get, the more value we can provide to the community. And we know that there are many, many libraries out there that are known to have memory issues and we're not tracking yet. So what you can do is maybe go back and check the leaky gem that caused you a big headache maybe a few months ago and check whether we are tracking it with the RubyMem Advisory DB. If the leak has been patched, or if the leak has not been patched, we recommend that you go to rubymem.com and submit it privately. Sometimes a memory problem could be a security issue, so we don't want to disclose it unless it's been patched. If the gem has been patched and the patch has been available for weeks or months, feel free to submit an issue to our project in GitHub. And finally, we are looking for contributors and co-maintainers. So if you're interested in helping out with this project, the best thing you can do is run Bundle Leak in your projects and see if they work or if there are unexpected behaviors that could be a bug. Next time you ask yourself this question, is it my code or is it a dependency? You can save yourself a lot of time. Next time you need to go down the rabbit hole, I recommend strongly that you use Bundle Leak first. And then you can pick the rabbit hole. You can go down the dependencies rabbit hole or the application rabbit hole. And hopefully it will save you a lot of time. If you're interested in this project, it's on GitHub. And if you have any questions, feel free to shoot me a message on Twitter. I'd like to give thanks to Sergey Alexev for creating the project that started it all, to Nate Berkopek for suggesting this idea for this really cool tool, and to my coworker, Luis Sagastume, for implementing these projects with me. Thank you very much for your time. I hope that you will take this tool and put it in your tool belt so that it can help you in your next performance optimization journey. Thank you. If you're interested in any more resources, feel free to check out these pages.